Is Google a bully? Google found a vulnerability in an open source volunteer maintained project, and I think rightfully so, the maintainer of that project was not super happy. To contextualize this, we got to kind of introduce FFmpeg, the world of AI vulnerability research, and the world of trillion-dollar corporations profiting off of free and open source software. Enter FFmpeg. FFmpeg is a complete cross-platform solution to record, convert, and stream audio and video. If you want to convert one file to another, to chop up files via the command line, or to stream video content, FFmpeg is the go-to guy. And they've been kind of the main player in this space for about 10 plus years. It's a very well-known and well-loved piece of software. So much so that this meme exists that says kind of that Pornhub keeps the internet alive, but more importantly, that FFmpeg is this little pillar where a couple guys commit code that keeps the entirety of video streaming on the internet in its place, which is true. YouTube, Twitter, TikTok, Twitch, Instagram, Facebook, and Netflix all use in some form or fashion FFmpeg, mind you, for free. Now, FFmpeg may be a well-known library in tech, but it's also a well-known Twitter account. You know, FFmpeg sometimes gets flack for its library being written in complete C and assembly, which is necessary, by the way, because it's a library that encodes and decodes video, and to do that quickly and effectively requires a lot of C and a lot of assembly. And so this guy here says your code base is a mess, and the reply is talk is cheap, send patches. Very strong, very based, okay? So through tweets like this, the FFmpeg Twitter account has become a little notorious for being, a bit loud, a bit boisterous on the Twitter. And so this is another example of that, and this is where Google comes in. So FFmpeg received a bug report from Google, and Google's AI, we'll go into what that means here in a second, and they weren't a big fan of the report that was submitted. We take security very seriously, but at the same time, is it really fair that trillion-dollar corporations run AI to find security issues on people's hobby code, then expect volunteers to fix it? This is a very good question. It's important to highlight, though, that the world of video encoding and image processing code is very well known for its vulnerabilities. It's very difficult to get video processing, image processing code correctly for two reasons. One, video codecs are very complex, and two, it is kind of the entire threat model of video processing that you are going to ingest and render an arbitrary amount of data from a user. If I text you a picture to your phone, there has to be a library somewhere that reads that picture, reads out the image data, and pushes it to the GPU. That process of parsing the image is where a ton of these bugs lie. One of them being this bug known as BlastPass, for example. The NSO Group, this big commercial spyware company, was exploiting a vulnerability in libwebp, a picture format, that you could just WhatsApp message or text to somebody and it would zero-click exploit their phone. It was explicitly targeting diplomats and politicians, so kind of a scary scenario. So as a result, organizations like Google have come up with kind of these projects to find vulnerabilities for free in open source projects. Their big kind of claim to fame here is OSS Fuzz. OSS Fuzz, or Open Source Software Fuzz, is this project where Google will ingest open source software like Apache, Nginx, FFmpeg, Boost, OpenSSL, and it will submit jobs that fuzz or inject arbitrary malicious data into the software with the hopes of finding bugs and mitigating the bugs to make the world, in theory, a more safe place. And so FFmpeg is one of the targets there. Now, where it gets kind of weird is the amount of money and the amount of compute that Google has that they can, in theory, overwhelm a small project like FFmpeg with bugs. And guys, one thing that keeps me up at night is if these bugs affect my code and, more importantly, my infrastructure. That's why I want to talk about today's sponsor, ChainGuard. Normal Docker images are not only full of bloat code, they're full of bugs. And also they're huge, 60 megabytes for the regular Nginx image. The ChainGuard team creates images that have 0 CVEs. On the right, we have the image that is not ChainGuard, the publicly available Docker image. And on the left, we have the ChainGuard built from source image. You'll notice two things. One, the one on the right has dozens of CVEs. CVEs, okay? ChainGuard images come with none of the bloat software that normal images come with, and as a result, it comes with none of the vulnerabilities. Also, you can go look at the software bill of materials inside of the image that ChainGuard ships. So if a big bug comes out and you think you might be affected, you can go look at the code that's inside of your image directly and be like, nope, that's not a problem for us. Also, ChainGuard has best-in-class CVE remediation SLA. What this means is while the ChainGuard team is out there fixing bugs, getting your critical CVEs gone in 7 days or less, your team can be shipping and working on actual software problems. ChainGuard has you covered. Guys, you can go check out ChainGuard right here with this link. The best way to help my channel is to go interact with the sponsors, give them a try, and reduce the friction in securing your code base. Thanks again, ChainGuard, for sponsoring this video. Back to the video. Now, this didn't actually come from OSS Fuzz. This bug came from Big Sleep. If you're not aware, Big Sleep is this AI-powered LLM system that is probably very closed source, very proprietary that Google has, but they've done a very good job of, as a trillion-dollar corporation, throwing so much compute, tons of compute, at projects like FFmpeg and finding vulnerabilities in them. Another one recently was in Apple's WebKit, which is kind of like the FFmpeg for Safari, for example. It's used to render and ingest web content. It found on its own, without human intervention, 5 CVEs, all of which were some kind of remote code execution, so buffer overflow, unspecified here, but memory corruption and use after freeze, that if exploited properly, a malicious actor could create a format of a file to use these exploits and get code execution on your computer. So in theory, this is a good thing, right? But here's where it gets a little hairy, okay? So the maintainer or the person at Google who is, keeping this ticket open, they give a breakdown of where the vulnerability exists. And at the very end of this, they say, hey, by the way, this bug is subject to a 90-day disclosure timeline. If a fix for this issue is made available to users before the end of the 90-day timeline, the bug report will become public 30 days after the fix is made available. Otherwise, the bug will become public at the deadline. The scheduled deadline is this date here. Now, where FFmpeg got a little upset, and I think rightfully so, this feels a bit like extortion in a certain way. Like, it is not maintainable, it is not scalable for a company like Google to be able to throw billions of dollars of cloud compute and of LLMs at open source projects and then just say, hey, by the way, you need to now go patch this or the bug will go public. Now, luckily for FFmpeg and for kind of the world, this particular bug was in a codec that FFmpeg refers to as hobby code. How hobby are we talking here? This patch exists to fix an issue with decoding LucasArts Smush codec, specifically the first 10 to 20 frames of Rebel Assault 2, a game from 1995. Now, while FFmpeg aims to play every video file ever made, that video file ever made clause comes with new code. The problem here is that FFmpeg had a vulnerability in a piece of software that literally nobody uses, and that if you compile FFmpeg from source right now, by default, you will not get this codec included. So FFmpeg's argument is, okay, so now you have this arbitrary disclosure timeline that I have to follow. I have no choice but to follow it or the bug will go public. Oh, and also it's in code that doesn't really affect everybody. I hear their argument here, but I want to kind of highlight a couple caveats to what they're talking about. First of all, FFmpeg called this bug CVE slop, and I'm not sure that I necessarily agree that it is CVE slop. CVE slop comes in a very particular form. So if you're not aware, this gentleman here on the left is Daniel Stenberg. He is the author and core maintainer of curl. If you don't know what curl is, okay. Curl is a library or a program and a library that are used for parsing and sending web requests on the internet, right? Very well-known, very highly used piece of software. And so Daniel Stenberg in several blog posts has highlighted that his project on HackerOne, a bug bounty platform, has received slop bug reports. Now, his slop bug reports are bug reports in curl that literally do not exist, okay? They are vulnerabilities in curl for pieces of curl that are not real or for vulnerabilities that don't actually cause crashes, right? Like for literally like the AI is hallucinating bugs and finding vulnerabilities that do not exist. One of them being here, someone used AI to write a harness that uses stir copy for curl, and then they fuzzed their harness and they found a vulnerability in their harness that because it used stir copy, there was a buffer overflow, and then reported that to HackerOne, to curl, and then Dan Stenberg had to go and triage this fake bug that doesn't exist. Oh, and then also argue with the author of this harness for, it looks like a couple days, to eventually realize, oh, this person used AI, doesn't know what they're talking about, and the bug isn't real, okay? This is much different than Google using AI. While we all may not like AI, our AI overlords are here, unfortunately, using AI to find and report a real bug, okay? That is, in my opinion, not CVE slop. However, there is a much larger issue here, okay? This particular bug is, again, in a codec that doesn't necessarily affect the average person, okay? It's a codec that is for a particular game that, again, if you compile FFmpeg by default from source right now, this codec will not be included. However, the inclusion of this disclosure policy, it starts to beg very interesting questions. I think the first conversation we have to have is like, what is the purpose of timed disclosure, okay? A lot of people on Twitter were saying that timed disclosure is more of like a clout gathering mechanic that researchers use, or that like people have disclosure policies so that they can report their bug on Twitter. And that's not necessarily the case, okay? The reason that bug disclosure timelines exist is if this bug is real and affects a lot of people, which is not the case for this one, okay? It is not a bug that affects a ton of people. But let's say it was. Let's say it's a buffer overflow in OpenSSL in the key exchange process, okay? A bug that is gigantic. You have a couple of options with how you deal with that. You can just go public immediately, but the problem with that is if you go public before maintainers have a time to patch, now attackers also have access to the code as well as defenders, and you're basically creating this race scenario where whoever wins is a function of how fast somebody can act, and maybe defenders can't be as fast as attackers, maybe there are time zone changes, etc. So then the option is don't disclose. Hide the bug, patch it, and then quietly patch it, okay? But the issue there is if you acknowledge the bug exists that you found, somebody else may have also found that bug and could actively be exploiting it right now. So at some point, you are morally obligated to disclose the bug to somebody to be like, hey, we need to patch this. So you go to the maintainers and say, hey, we need to make this bug go away. If we don't, people can keep getting hacked, and we have to do it quickly because they could be getting hacked right now. You're trying to reduce the amount of risk that a person is exposed to, okay? Now, as a result of this, the researcher that finds this bug may get clout. They may get brownie points in the security research world, okay? But that is not the intent of disclosure timelines. It may be a side effect, but if people are doing forced disclosure for the sake of internet hacking points, they're a bad researcher. They're not in it for the right reasons, okay? So my opinion on this is that this disclosure timeline was put in there literally automatic. I think this is literally boilerplate code that Big Sleep puts in. You can even see for more information, visit google.com/big sleep. So I think that this is maybe getting people more mad than it needs to. While it does highlight a bigger issue about disclosure, it is not necessarily, I think, something that like Google was doing for the sake of like cyber extortion. I do want to highlight though that it does create this kind of weird issue where you do have these like multi-bajillion dollar corporations that are standing up all of their code, all their profit off of single like volunteer organizations. And so maybe the answer is that Google, while they submit these vulnerabilities, should also be submitting patches. But then it begs this bigger issue of like, okay, but if they find the bug and can't create a patch, do they just hide the bug until they have a patch? Do they submit the bug and then submit a patch? I don't know. The thing about this one is this is a use after free vulnerability. You know, it's not a great way to solve this. One thing you could do is just find where the UAF happens, and when you free it, set the pointer equal to null, right? It would still turn the vulnerability into a DOS condition, a denial of service, but it would not make this state executable or exploitable in a way that an attacker could take advantage of, right? So again, I think that FFmpeg is right in that, hey, Google should probably put resources into not only finding the bugs, but for helping these small organizations to report and mitigate the bugs. But at the same time, I don't think it's right to necessarily call this bug CVE slop, because I just don't think it is. Again, for the record, guys, this is not meant to be some like, ooh, I'm starting a flame war with FFmpeg. I'm literally just having a conversation pretty much with myself and the camera. If you have an opinion on this, please let me know in the comments below. If you're a maintainer at FFmpeg or somewhere else that has dealt with this, I would love to know your opinions. Either comment down below or DM me on Twitter. I have 6 notifications. I'm kind of a big deal. And then, yeah, from there we can go hang out on the next video, which you will also enjoy probably as much as this one. I appreciate you guys watching. Thanks. See you next time. Goodbye.